The problem is that we also have to keep a track of when they leave the page. So when they leave the page, we also have to decrement, and then we also have a along with the user will set up a socket connection with the server. Once that socket connection is set up, after that we will be setting the. Okay, so let's now move on to the implementation. Let's start coding something. Let's do something with this. But before that, we also have to take care of one more thing, and it's that whenever a user tries to access something from the backend, so the users in the initial stage, so these users are going to get access to the backend. They are not being pushed into the queue. So for these users, the problem is that we also have to keep a track of when they leave the page. So when they leave the page, we also have to decrement this user's count and all of these things. So for that, what options do we have? So one option we have is that we can add an event listener. So we can simply do a window.event listener, and in that, let's say we have something like before unload. There might be some event like before unload. Let's check that. Before unload. Yeah, so there is an event before unload, window dot before unload. So before unloading the window, we can simply add an event, and we can send a request onto the server that the user has left the page. But the problem with this occurs when there are different users who are trying. There are more than these users. So all the users who are supposed to get into the queue, if these users try to access the backend, because first and foremost, what they are going to do is they are going to go to the front end. The front end has something which is going to fetch something out of the backend. Now, when they are trying to fetch something out of the backend, at that time the middleware checks for all of the limits, if the limits are reached or not. Now, in this case, if the limit is not reached, then we send an event, or we send some notification onto the user side, so as for the users to redirect. Now, the thing is, at this time, we already have loaded the front end of that route, like of the route that the application is residing on. And when we are redirecting from that route, we need to uh, okay, so yeah, so when we are redirecting, the windows will change, right? So the present window will unload, and then we will be redirected to another window, right? So this event this event listener will be invoked at that point. So to prevent that, we will have to establish a WebSocket connection of these users as well. So whoever is currently interacting with the backend, who has an access of the backend, will also be connected via WebSocket to the backend. Along with that, people in the real-time queue will also be connected via WebSocket to the backend. So in a real case scenario, maybe the people in the real-time queue will not be very high, will be almost half of the people, those who are allowed to access the backend. And that would do it, because what is more important is that the users who are currently on the backend don't face any problem, and the backend server doesn't collapse. So, yeah, so this is what we will be trying to do. Let's see, let's start coding, let's do something, and maybe we'll figure some things out while we start coding, and maybe there might be something that might work or might not work as well. So, let's see how it goes. So, first of all, I'll just create some basic front end using React, and then we will start with the back end for it. Okay. Okay, so we have this front end setup, which is a very basic front end. So this is the waiting route, and this one is the normal route that we have. Now let's okay, so now let's see what we can do next. We can set up our backend first. We will just set up the backend and start with the and start setting up the socket server as well. Fine. Okay, so I will also have to connect to the socket from the front end now. Okay, fine. So the basic backend and front end is set up. Now the next part is that we have to implement all the logic that we have thought through, and let's see how we can do this. So we will first declare two things over here. One would be okay. So I'll just okay. So these are the configurations that we need. Now here, let's have a real time queue. And then we also have along with the real-time queue, we have an endless queue also. Along with that, let's also have users on board, and that would be initially zero. Let's call it let. And apart from this, so anything more we need? Okay, so for now, let's go with this. Let's see what comes up ahead. Okay, fine, fine. So now the next part would be to create some route handlers. Let's say we have a route handler app.get, a default route handler. We will have a request and response coming up. We need to do something here. We need to give some data out to the user. So the data that we'll be giving out to the user would simply be response.send. Uh, let's say we have a message. We have the user count in real time. User count would be users on board, and that's it. We will also send the status 200. Right. So for now, let's keep it this way, and we'll have to add a lot of things out in here. Let's see how we can do that. Okay, so now the next part is to for the React application to connect via WebSocket to the server if the limit is not reached. And if the limit is reached, then we will have to redirect to waiting. Okay, fine. So as soon as the user hits onto this route, I mean by default the user will be hitting onto this route itself. Now a user may directly hit onto the route waiting, but that would be another scenario for us to handle that we'll see. But by default, the user is going to hit on to this route, and after that, or else, I mean, for an application, even if a user hits onto any of these routes, the first part would be to get some data of the user, and that data has to be obtained from a backend server. And for that, for any route, the first thing would be that you need to hit onto a backend endpoint, and that would be this default endpoint, which will give us some information of the user. So currently, we are putting out this user count, which is obviously not of use, but in a real scenario, there might be some data that is the data fetching that is being done from the database, and then that is being sent to the user. So that would happen in case in any of these conditions, in any of the routes that are defined, the user would first actually uh, go to the API and then figure out what has to be done next. Let's go to home.jsx and let's try doing something over here. Okay, fine. So first of all, what we'll be doing is we will have a use effect hook, fine, and this would be executing only once. So we'll have an empty array, empty dependency list, and the use effect hook. As soon as the page loads, the first thing that it will be doing is to fetch some data from the user, and that would be user count. Let's say data const data comma set data equals use state of nothing, right? Okay, so let's keep it that way. Along with this, we'll also add the use state hook. With data, we will say it's zero currently. Okay, so let's declare a function over here. The function would be fetch data is in. And we will the thing that we'll be doing is we will obtaining a response using fetch API, fetch from HTTP localhost 8000 slash, and yeah, so from here we'll be fetching the response. Once we get the response, we will say convert it into JSON, response.json, also adding an await here. Once we do that, we get response in the form of JSON. I guess it should be in this way. Once we do that, we can now pass this JSON thing. I'll just log it into the console first. Let's see how that works. And in use effect itself, I'll just call this function. Okay, fine. Okay, so there's a cause error. For that, we can simply in the front end, we'll have to allow all types of calls app.use. Okay, so that works. Once we are out onto the application, we'll get this data from the front end. Now, when we send this request, when the request is being sent from the user, from let's say home.jsx. Yeah, so here we are sending the request and we are waiting for the response. In the meantime, what the app.js will do is perform the checks that we had already discussed upon, and once those checks are performed, then we can do whatever we want to. I mean, the user can do whatever the user wants to. Fine. So let's do that. Let's see what we are up to. First, we need to create a middleware where check if the user's limit is reached. If not, proceed. And if not, then see if the real-time limit is reached. If the real-time limit is not reached, then set up a WebSocket connection and push if not, then push the user to the endless queue. Check if the user's limit is reached, and along with that, I will also set up a web socket, set up a WebSocket connection, right? So yeah, these are the two things that we are going to do. First of all, whoever comes onto the website, he will be setting up a WebSocket connection with the backend server, and then we can go ahead with the other operations, right? Okay, so now the task is to create a middleware. So let's go and check how to work with middlewares in Express. So for any path, we need to run this middleware, right? Because the user may try to try to request from, let's say, if a user like me who uses Postman, I can simply find this route out from the console in Chrome, and then I can simply hit onto this route from my Postman by creating the request object and whatever if I just figure it out in some way. But the problem is that we don't have to let that user also access the server. So that is why we will be adding this app.use by default for every route. So using this syntax, we can make it default for every route, and every route will then be checking this, I mean, executing this middleware before going to the route handler, right? So let's do that. Let's create this middleware over here. So I'll say app.use request response next, and then let's start the middleware. So for the okay, so I'll just create this function separately. Let's say const perform checks request response next, and I'll add this up here, perform checks. Okay, so let's see now what we are going to do. First of all, check if the user's limit is reached. Okay. Okay, so the limit that we have is 3, and for the real-time queue also we have a limit as 3. So check that first. If users on board is less than 3, then we may simply increment users on board Okay, so this we will do in the request. For now, we will just return out of this function. If users on board is less than three, then we will just increment users on board here itself, because we can't be relying on the fact that the user will first of all hit this route only. The user can hit any of the routes that are defined in this application, right? So first thing is to increment users on board, and then we will return along with that. Okay, so let's send a response here. Let's see how this works. Even I don't know how this is going to work out, but let's see. Send message access granted file. This would be the thing that we'll be doing. If users on board is less than three, and so there might be a situation where users on board is less than three, but for that fraction of a second, or for that 1 or 2 seconds, real-time queue and endless queue are also filled. There is only the application is only waiting for the real-time queue to release the first element out of it. So for during that time, if a user hits onto the backend, then there will be a problem, and only this check will not suffice. So for that, we will also add another checks like how many people are there in the real-time queue and in the endless queue. So if users on board is less than three, and real-time queue dot length equals 0, and endless queue dot length equals 0. So we obviously will write code such that the endless queue length has not to be checked, but let's keep it for safety reasons. And now let's also add, if users on board is less than 3 and real-time queue dot length is equal to 0 and endless queue is 0, then fine. Let's increment users on board and send the response as access granted. If users on board is equal to 3, because it's not going to go over 3, and real time queue dot length is less than 3 and endless queue dot length equals 0, then in that case we will be pushing this user into the real time queue and setting up a WebSocket connection with the user. Okay, so a message access granted, and also I'll be sending queue, which queue we are going in. Let's say none in this case. Okay, so access granted and queue is none, fine. In this case, we are not incrementing anything. You will just send the response. Send, it would be message. Message would be access denied, and the queue that is assigned would be the real time queue. Okay, so this is it, and return out from this. After that, we will also have another condition where if users on board is 3 and real time queue dot length equals 3 and endless queue dot length. Okay, so we don't have to deal with the endless queue dot length. Now, if that is the case, I guess, okay, so that should work, no problem. 200 dot send message would be access denied, and the queue that we are supposed to get into is endless. Okay, so this is endless, fine. So these are the checks that will be performed by our middleware, and hopefully that works. I don't know if we are sending this response again, what actually we'll be getting on the front end. So let's see, let's try doing something. Uh, Access granted, queue none, fine. But now, if this user tries to again interact with this application, then it will create a problem, because whenever you send a request, it will be considered as a new request. Okay, so this is a problem. So basically, our aim is to give full access of the application to the user, so that for the time that the user is on the application, the user can hit onto anything, the user can hit onto any APIs, and that should be allowed. So that can be done using that cookie, using that token that we get out of the socket ID connection. So now this has been the mandate that the users have now is that they have to set up a socket IO connection in any condition. So be it that you are in the endless queue or in the real-time queue, you have to set up a socket IO connection, and you will also get a socket ID. With every request that we will be sending, we will send the socket ID so that we can keep a track of user throughout the application and not lose context of that user. Fine. So, and in this case, obviously, other users who are in the endless queue, they will also not be able to get access to the backend backend server, right? Okay, so let's do that. We will also check cookie. Okay, if cookie is not defined, then only all of these conditions will be taking place. If the cookie is already defined, then we don't need to do anything for that, right? Okay, so let's do that. If res.cookie, if res.cookie is undefined, let's say if not of res.cookie, otherwise let's say if res.cookie, if we have a cookie, then we need to simply return out of this function and do nothing. But if not, then we will be doing all of these things. Along with that, we will also be setting that cookie so the message access granted is taken up by the user. When this message is taken up by the user will set up a socket connection with the server. Once that socket connection is set up, after that we will be setting the cookie. So all of this has to be done in every route that we find. Okay, so okay, so let's go with the chronology. Let's not think a lot. Let's go with the chronology itself. Now that the response is obtained, we'll check for the response. So we'll say if JSON dot message is access granted, then we will simply set up a WebSocket connection. I'll create a function socket setup socket connection. Okay, fine. We'll declare this function here, setup socket connection, and let's see what we can do in this. We'll have to set up a socket IO client, so I'll say import const socket equals IO URL. So let socket, and while setting up the socket connection, we will set socket as IO HTTP slash local host of 3000. Fine. So on this, we will be uh, setting up the socket connection. Once the socket is connected, we need to see on the server that the user has connected. Fine. Okay, so let's do that. The cookies. Okay, so rest.cookies is undefined. Okay, so that does good for us. Client is connected. Okay, so once the client is connected, I'll have to save it to the users list, and when it is in the users list, I'll perform a check again that if the client is connected, we don't have to do anything. Okay, fine. One thing, we will also put it in the users. So const users connected equals an empty array, and const users real time queue, the users who are in real time queue, for them also we will maintain an array. And okay, so real time queue itself is an array, so never mind. In the real time queue itself, we will store all of these things. Okay, so once the client is connected, there is no way going back, right? If the client is connected, the client is for sure in the real-time queue or in the users connected queue. So Okay, so that is fine. If the client is going to go into the endless queue, the client will not get connected at first. Fine. So once the socket connection is set up, if the client is going to go to the endless queue, we won't come up at this line of code, right?